The second part of our lesson today, I am going to talk about compound interest. And I've written the formula for compound interest, and if you'll notice, it's very similar to what we had for exponential growth right here. Notice the only difference is I've added a variable n, and n is added in two places. If you look at your growth formula, you have 1 plus r in parentheses. Well, for compound interest, it's always going to be growth because you are always earning interest. So that's going to be added to your original amount. But you're going to divide it by n, and then you're going to multiply your time, which is your exponent, by n as well. Now, what in the world does n mean? N has to do with the money being compounded, and there's certain ways that you can do that. So let's go over each variable. Again, P is going to be the principal amount of money, what you're starting out with. R is going to be the rate, which is the percent that you're going to change to a decimal. T is the time in years, but now N is going to be how it is compounded, and it can be more than one thing. So when you're reading these problems, you're going to see compounded yearly or compounded monthly or compounded quarterly. So let's look at N and how it's compounded. There are certain words that you're going to translate into values. So, if something is compounded yearly or annually, then the value of n is going to be 1. If something is compounded monthly, then how many months are in a year? 12. So n will be 12. If it's compounded quarterly, you think how many quarters are in a year? How many quarters are in a dollar? There are 4. 4 quarters to a dollar, 4 quarters to a year. So if your problem is saying that this is compounded quarterly, the value of n is going to be 4. Now we also have weekly. So how many weeks are in a year? 52. And we do have compounded semi-annually. That means twice a year. And so in that case, n is going to be 2. We do have one more, and it's called continuously. What that means is this is compounded every day, every second. Well, how many days are in a year? 365. Now, normally for continuous compound interest, we use a special letter, E, a value E, and there is a totally different formula for that, but we would use the calculator to compute that, and most calculators have the value of E already in it. If you have a smartphone and you turn your calculator sideways, you will see E to the X power button on your calculator. But I cannot assume that everybody has one. So we can also figure out continuous compound interest by letting the value of n be 365. It'll be off maybe 1 or 2 hundredths from if you had used the value of E to compute this instead of 365. So today we're just going to stick with 365. So I want you to look at the first compound interest problem that I have. And it says you start an account with $500 and an interest rate of 6%, compounded yearly. How much is in the account after 3 years? So do you see the word compounded and then you see the word yearly after it? That is your N. And that's where you need to come back and look for, okay, yearly meant 1. So N is going to be 1 in this case. So for this particular problem, our P, and this is actually example 3, our P, we start with $500. The rate was 6%. So again, I'm going to change that to a decimal point, 0.06. And then we're going to have 3 years, but it's compounded yearly. That means n is 1. And so what we're going to do is we're going to substitute 500 for P, 1 plus, and now we're going to have 0.06 divided by 1, like that. And then the exponent is going to be 1 times 3. And again, you'll want to do this in the calculator, and if you have to use just your calculator on your phone, then you'll want to do the parentheses first. And it's really going to be simple because your value of n is 1. And so if we do this in the calculator, we're going to end up, now I'm going to write down what we get as the answer. Now, obviously, if we're talking about money, we don't have 50 cents and then an 8 there. So that 8 is going to tell me to round up that 1, or round that to a 1, I'm sorry. And so your answer is going to be $595.51. Okay? If we look at example 4, $1,000 is left in a credit union drawing 7% compounded monthly. So this time your N is going to be 12. What is the balance at the end of 10 years? Okay, so number 4, we have $1,000, and so that's going to be P. The rate is 7%, so that's going to change to 0.07. This is compounded monthly, and so I'm going to put N equals 12, and it's wanting the balance after 10 years. So the value for T is going to be 10. So your formula is going to be 1,000, and then times 1 plus 0.07 divided by 12, and then your exponent is going to be 12 times 10. So when I put that in the calculator, 1,000 times 1 plus 0.07 divided by 12, and that's going to be to the 12 times 10 power. We get this value, $2,009, and then I see 661377. So I need to go to the nearest hundredth. Remember, we're talking about money. So this 1 tells me leave 6 alone. And so your actual answer is going to be $2,009.66. Let me move that over so you can actually see it. Okay, one more example. Example 5. You deposit $600 in an account at 4% compounded continuously. Okay, what will be the balance after 5 years? So this time, we're going to be using the value of 365 for N instead of the letter E, or the value of E, just because we're having to do this with regular calculators. So this is example 5. Again, P is your original amount, or your principal, which is $600. R was 4%, so when I change that to a decimal, I get 0.04. This is compounded continuously, so N is going to be 365, and the number of years is 5. So here is how we're going to place everything. 600 times 1 plus 0.04 divided by 365, and that's going to be raised to the 365 times 5 power. Now I'm going to actually do this in the calculator right here. So that's going to be 600 times 1 plus 0.04 divided by 365, and I'm going to raise that to the 365 times 5. Okay, so you see we have 732.8336244. Again, we're going to the nearest penny, which is this first 3 right here. So if I look at this 3, it tells me leave that 3 alone. And so my answer is going to be $732.83. So P equals $732.83. Okay, so your assignment, I've given you about 5 problems that are exponential growth, decay, and compound interest. And so those will be posted in Google Classroom. Let me know if you have any questions.